2D and 3D translations follow almost the same formula. An additional axis is added to the 3 dimensions. In this example, 4 points are given A031, B332, C300 and D000, which are 3-dimensional. We have to apply translation factor 1 in every axis. We will apply the translation formula to each point A, B, C and D according to the given factor. This will give the new coordinate for the given object. Here again in case of scaling. 3D scaling and 2D scaling follow the same formula. We just need to multiply the scaling factors with the dimensions. For separate points A033, B336, C301 and D000 are given in the example. A scaling factor of 2 for x-axis, 3 for y and z-axis have to apply to these points A, B, C and D. "3D rotation is slightly different from 2D rotation. For that we have to remember some formulas. For x-axis rotation, nu x equals x, nu y equals y cosine theta minus z sine theta. Nu z equals y sine theta plus z cos theta. For y-axis rotation, nu x equals z sine theta plus x cosine theta. Nu y equals y. Nu z equals y cosine theta minus x sine theta. And for z-axis rotation, nu x equals x cosine theta minus y sine theta. Nu y equals x sine theta plus y cosine theta. Nu z equals z. Given point A123 in 3 dimension. We have to rotate it 90 degrees and obtain the new coordinate. We apply the formula on x, y and z axis and find the new coordinate. "3D reflection can be of 3 types. Reflection relative to x-y plane or y-z or z-x plane. In x-y plane nu z will be negative. In y-z plane nu x will be negative. And in z-x plane nu y will be negative. Now we apply the formula for x-y plane for given example and obtain new coordinate point for A.
"3D shearing can be of 3 types. Shearing in x-axis, y-axis and z-axis. Nu x will remain same for x-axis and so for y-axis y will remain as it is, also z will have no change in z-axis. Other 2 point will change according to the formula as given. Three points of a triangle in a 3-dimensional space are given as A000, B112, and C113 respectively. Apply a shearing parameter of 2 along x-axis, 2 for y-axis and 3 for z-axis on this object. For x, y and z-axis, we have to apply the shearing parameter formula at each separate point. For the x-axis at the beginning, After applying shearing parameter of x-axis, the new points will be A000, B112 and C136. We can see the process of extracting the points on the display. We will apply shearing parameters to the y-axis as like the x-axis. After y-axis shearing, the new points will be A000, B315 and C316. Similarly, after z-axis shearing, the new points will be A000, B552 and C773.